Okay, let's do this. All right, this is lesson 11, and we're going to do page 126, 1 through 8. All right, so 126, 1 through 8. Let's take a look at number 1, shall'n we? In his job as a cashier, Joe makes $500 each month. I like information that I can extract. That's important. So, boom. Plus $20 every time he convinces a customer to open a charge account. Okay? So there it is. That is the pertinent information. Okay, let's write an equation that describes Joe's monthly income, I. Okay, so it's not going to be Y equals, it's going to be I equals, because they asked me to show the income as I. So I equals, this is your rate of change, $20 every time he convinces a customer to open a charge account. So $20 times C, where that's going to be charge account, plus we know he always makes $500. So every time he gets a customer to open a charge account, he gets $20 extra. If he gets 0 customers to do that, then this just turns off and he gets his $500 paycheck. So that $500 is always there. What varies is how many $20 increments he gets based on that. So I equals 20C plus 500. I'm now going to go to the next page. I'm going to rewrite that equation up here. I equals 20C plus 500. Okay, the function is definitely linear, right? There's a number times a variable plus a constant. There's no exponents. If it was exponents, it would be exponential. This function is discrete. We jump. So when you have things that jump, that's discrete. So we jump by $20 increments. The domain, we're going to do it 2 different ways. We're going to do interval, and we're going to do inequality. Okay, so interval. What's the minimum number of customers? 0. Maximum? We don't have a maximum. Okay? So inequality. Boom. C is our variable. Remember, the bracket means inclusive or included. So 0 people is possible. That means not included. Infinity is a concept. It's not a number, so I can't include a concept. All right, let's do number 2, right? The equation of the line with a slope of -1. Okay, so I know it's an equation of a line, so it's that. I know I have a slope of -1, so it's that. Now I'm going to use my x and my y to find b. So I'm going to let my y be 5. So I'm going to substitute 5 in for y. And then I'm going to substitute -2 in for x. And I got that from right there. Multiply those together. Inverse operation, subtract 2. And there's my b. So that means now I know my final equation. Boom. Okay, so there's my equation. I'm going to now answer some questions. That is definitely a linear. By the way, they told me line, so it's linear. It's a generic graph, so anything that doesn't have a context, anything that's not a word problem, is continuous. The domain, anything that's not a word problem, that's just a generic graph. The domain is going to be interval, -infinity to infinity. Any x value works. There's no restrictions on x. Inequality. Remember, the domain is the input values. Boom. There we go. Moving on. Number 3. Write the equation of the geometric sequence. Boy, right there it tells me exponential. Right? With a constant ratio of 5 and a first term of -3. Okay, so it's y equals a times b to the x. That is my constant ratio. That's the b. So y equals a 5 to the x. A is the 0th term. So if my first term is negative 3, my 0th term is going to be negative 3 divided by your constant ratio, which is 5. That's A. So your final answer is y equals negative 3 over 5 times 5 to the power of x. Or, if some of you out there wrote a decimal, that's okay. Oof. Sorry, I got a little crunch there. So notice that and that are equivalent. As long as your decimal terminates, as long as it ends, we're good. Okay, next page. This is a generic equation, so it's continuous. Domain, the domain are all possible x values. Okay, so interval and inequality. Okay, so interval, boom. It's a generic equation. X can be anything. Generic equations, x can be anything. All right? So that's negative infinity to infinity. So if I give you a graph, or if I give you a y equals a non-word problem, then that's going to be negative infinity to infinity. Here's number 4. Write the equation. It's a line, so it's linear. So get that one right. Y equals mx plus b. M is the rise over run. So I'm going to go from there to there, up 3 over 4. That's my m. Your b is your y-intercept. Your y-intercept is right there. That's negative 3. So I got everything I need. Y equals 3/4 x minus 3. That's that equation right there. It is linear. We see that. It's continuous. If it was not continuous, then the graph would look like that, right? It would be jumps. So continuous, they connect them. Solid. All right, and then the domain, it's a generic graph, generic equation. So the domain, which is going to be interval and inequality, is going to be negative infinity to infinity. Negative infinity less than x less than infinity. Boom. All right, here we go. Numero 5. The population of the resort town in the was estimated to be 35,000. Okay, so a rate increase. Okay, whenever we have a rate increase, we know it's exponential. All right, so y equals a, b to the x. That is your initial amount. So that is your a value. To find your b value, remember, you always, when you have a percent problem, you always start with 100%. We're increasing. So we're adding 2.4% to that. So my b is 102.4%. Percent means divide by 100. And when you divide by 100, you get, oh, getting off the screen, you get 1.024. That's B. So I know my A, I know my B. Here's my model. A is 35,000. B is 1.024. Power of x. That's my model. That's exponential because the input value is the exponent. All right, so the function is exponential. The function is continuous. Well, people can't be fractions, so I don't think it is continuous. I think it's discrete because you're dealing with people. So I can't have a half of a person. So the outputs have to be 1, 2, 3, 4, 35,000, right? It's got to be whole numbers. So this is discrete. The domain, interval, inequality. Okay, so the minimum is 0, and that is inclusive. There is no max. Minimum is 0. Inclusive means equal to underneath that. There is no max. All right, let's keep going. Number 6, Jessica. Okay, boy, what I noticed right away is that if I add 1.2. All right, so that's a common sum. So that means we have linear, because common sum means linear. Common multiplier means exponential. Go backwards to find your 0th term. So 1.7 minus 1.2, because that's the opposite of that, is 0.5. So I got y equals 0.5 times x. That's not true. I'm backing up. Boom, boom, boom. Y equals 1.2x, because that's how we change by 1.2. So that's the rate of change plus your initial amount. Boom. All right, that is definitely linear. Y equals mx plus b. Week and height, that's continuous. Height is continuous. You're constantly growing. The domain, interval, inequality. All right, so minimum, 0, right? 0 weeks is your minimum, and inclusive. We have no max, and 0 less than or equal to x, less than infinity. Okay, there we go. Oh, growth of a plant. That's growth of a plant. That's totally continuous. Okay. Let's see what number 7 and 8 do for us, and then we'll be done. What do you know from the equation that helps you to graph the equation? Well, I noticed that I have a y-intercept of 0, negative 5, because the b is always the y-intercept. And I know I have a slope, 1 over 2, which is my rise over my run. So let's graph it. 0, negative 5, that's your y-intercept. Rise over run, up 1 over 2, up 1 over 2, up 1 over 2. Woo! You're done. That's continuous because it's a generic graph. All right, right here, what do you notice? Whoa, I notice that I have a initial value of 1. And I know that because there's no number in front, so it must have been 1 times 2 to the n power. Because we always have to have an initial amount. But because there's not 1, it must be 1, because 1 times 2 to the n is 2 to the n. And I also notice that I have a common multiplier of 2, because that's this right there. All right, so let's find some things. Let's find, I'm going to make a table, x, y. So x, 0, 1, 2. It should be n and y, sorry, n. So n, 0, 2 to the 0 is 1. Put in a 1, 2 to the 1 is 2. Put in a 2, 2 to the second is 4. Put in a 3, 2 to the third power is 8. That's enough. So 0, 1, 1, 2, 2, 4, 3, 8. This graph is going to hug that x-axis but never cross it. And it's going to shoot up real quick, just like that. That is that. Woo, let's go. Hey, how about we continue? We do a little level up. Let's level this thing up now. All right, so we did all of this today. We did those, and then we did this level up. Let's do it. Okay. All right. Oh, I'm throwing things all over the place. Here we go. Level it up. Given the graph, determine if this is true. It's a curve. Subtract 4, subtract 4, subtract 4. So that is a common difference. Common difference is linear. Common multiplier, exponential. I'm going to make a table for this one. I'm going to make it up here, if that's okay. What do we got? We got day, and we got pennies. He starts with 1 penny on the first day. So 0 days, 0 pennies. 1 day, 1 penny. On the second day, he collects 2 more pennies. So 2 more means he's adding 2. On the third day, he collects 3 more pennies. Adding 3. Add 1, add 2, add 3. So it's not a common sum. multiply by 3, multiply by 2. It's not exponential. That's neither. It doesn't fit a pattern of a common sum or difference, and it doesn't fit a pattern of common multiplier or common ratio. So, boom, done. Level up, 1, done. Number 2, write the explicit equation. That's exponential. Y equals what? A times b to the power of x. See that number right there? That is your initial amount. That is A. So A equals 3. Notice this graph goes through there. This graph goes through there. Those are what we call lattice points. All right? So, my y value is 3 here. My y value is 6 here. My y value is 12 here. Notice 3 times 2 is 6. 6 times 2 is 12. So your multiplier, your b, is 2. Because that's what I multiply this y value to get to this y value to get to this y value. Here's my equation. Y equals your initial amount. Your initial amount is 3 times the multiplier to a power of x. All right. Oh, I should use f of x here. Look at that. See how they gave me that as f of x and not y? I'm going to do that because that's the proper thing. That's proper. All right, this is continuous. You can see that it's continuous because you can draw the whole graph without lifting up your pen. The domain, there's no restrictions, so inequality notation and interval notation. Boom, that's done. Level up 2, done. Level up 3. Well, this looks familiar. I swear I just did this problem. That's minus 4, minus 4. Okay, so you have a common difference of minus 4. Look at that ordered pair. See how your input is 0? So that means your b is 3. Your m is negative 4. So equation, f of x, don't get caught in that one again. F of x equals negative 4x plus 3. This is continuous from negative 2 to 2. But notice it starts here and ends there. So when I do my domain and range, inequality notation is from negative 2 less than or equal to x less than or equal to 2. Interval notation, bracket, because it's inclusive, comma, 2, inclusive. That means every number between negative 2 and 2. All right, so I can have values like negative 1.5 or negative 0.3 or 1.2. I can have those as well. Okay, wow, this is going quick. Moving on. We're going to change this. If you did not, we're going to 1,000. Okay, so let's change that to 1,000. Create a linear model. Okay, this is weird because it gives you initial amount and day 2. So this has a gap. Initial amount. Day 1, I don't know. Day 2 is 1,000. Linear. So to write the linear, I take the second term minus the 0th term. And then I divide that by the number of jumps. So 1, 2. So 990 divided by 2 is 495. Okay, let's see if it worked. Add 495 to that. 505. Add 495 to that, you get 1,000. It worked. That's awesome. I love that. Okay, and notice how we have the b value, right? The 0th term right there. So we're ready. Y equals 495, because that's our common sum. We add 495 every day, times x, plus you started with 10 of those little flies of fruit. Okay, same exact thing, except now we're doing exponential. But notice there's still a gap. Okay, but now we do it differently. So instead of doing that number minus that number, we do that number divided by that number. And then we look at the jumps. And we take this to the 1 over jumps power. So I jumped twice, so 1 over 2. That gives me 10. 10 times 10 is 100. 100 times 10 is 1,000. So it works. Also, I have my initial amount. So I have my multiplier and I have my initial amount. Boom, you're done. Moving on. Level up number 5. Using the information provided on the table of unit. Okay, 0, 1, 1, 2, 2, 4. 1, 2 would be right there. 2, 4, 3, 8. This looks familiar as well. All right, boom, that's enough information to get that graph. Oh my gosh, that's terrible. Terrible. All right, let's do this one. 0, 5. So x0, y5, 1, 9, 2, 13, and 3, 17. This is definitely linear. Look at the difference between that straight line and that curve, right? So exponential, linear. All right, as the inputs for f(x) increase, which function produces larger outputs? F of x does. How do you know? Multiplication by a number greater than 1 increases quicker than adding. Okay, so multiplying always increases more than adding as long as the number you're multiplying by is greater than 1. I think that's it. I dominated that level up today. Dominated it. Woo! I feel so good about what I've accomplished in 22 minutes. Have a great day. Stay strong. Be good. See ya.